Okay, hello everyone and welcome to Handmade Hero, the show where we code a complete game live on Twitch. No engines, no libraries, just us. Even our renderer we wrote by hand, and not like GPU renderer, but I mean literally we wrote the whole thing by hand. Every last pixel is put there by us on the CPU, if you can believe it. And we still run at 60 frames per second. How do you like that? Just a little bit of old-fashioned elbow grease. You never know what's possible. You really don't. Anyway, we're in the middle of doing some asset work, and I want to sort of get right back into that because we kind of ended at a good place last week, and this week is going to kind of be about actually exploring the system that we set up, and hopefully coming up with a definition of what our asset pack file will be, so that I can make one sometime off the stream and have a new asset pack file for us that will, conform to the standard that we want it to conform to. Okay. Before I get started, though, let me just say it's day 136 here on Handmade Hero. So if you have pre-ordered the game and want to follow along at home, unpack day 135's source code. That is the source code that I am starting with today. And so that is the source code that you will want to start with if you want to match what I am doing. I have an itch on my back. Can I just say that? Am I allowed to say that on stream? My back is itchy. I need one of those little, like, hand scratcher thingies that they sell, those weird things where you're like, why would anyone want this? Well, right now is literally the time that I actually do want that thing. Okay, so we have everything running through our new asset system, which we worked on last week. And it all streams in assets progressively and all that other kind of good stuff. But there is a separate aspect of the asset system that was not just about streaming that we've been working on lately. And what we want to do is we want to explore that now, because that's a pretty important part, a pretty important thing that we were trying to accomplish. And so we want to kind of look at that and see if we can start to define it a little more rigorously. So if you remember, what we were talking about was how we could go about, and I sort of proposed this tag system that we put in there, how we could go about classifying assets in ways where the engine could use those assets without really knowing the specifics of what it was doing. And the reason that that's interesting is because what we'd like to be able to do is have the engine just sort of talk in a general way about what it is looking for in terms of a particular asset. Like, I need a hero sprite here, and I need them to be like pointing upwards or something because the hero's moving upwards or something like this, right? It'd be nice to be able to say that from the engine into the asset system, and then the asset system go and get whatever the most appropriate asset is for that thing. And there's a lot of reasons why you might want to do it this way. One of the big reasons is because you can add assets after the fact and not have to do any additional work in the code to make the game a little bit richer. So for example, let's say that we had some way of telling the asset system which direction the hero was facing, and it would return the sprite that most closely matched that direction. Well, once you do that, in the future, you can always put in more facing directions for the hero, and everything will just magically work, right? The game just gets a little more fidelity at that point, and you didn't have to do any more work in the engine, right? And so rather than have to write that code everywhere in the engine, where every place in the engine where we might be doing something where there could be there could be different numbers of art assets depending on how much art we have finished and all those other sorts of things. Rather than have to duplicate all the time, if we can just put that into the asset system, it's a lot more useful there, because then everybody who ever asks for an asset can ask for it in a way where it's not talking about a specific asset, but rather a family of assets, and it can trust the asset system to return back to it whatever asset is most appropriate. Then as the pack file gets more assets in it, the game just gets richer, and you don't really have to do any additional work, right? So that's kind of handy. It also helps during development because, for example, let's say that Yangshin hasn't drawn a particular thing yet, but I need to test that thing. I can always have a way of asking the asset system for it and having the asset system just return me something close that's like some other thing that hasn't, that's in the asset pack file but isn't exactly the right thing, and then I can still test out everything with that, and then later when she actually delivers whatever the stuff is that was for that new thing that was added, it just goes into the asset system, and then suddenly the game has the right graphics, right? And there isn't like this huge stall of me having to wait for her to give me back the thing before I can implement it or any of this sort of stuff, right? So it helps kind of like with that pipelining. That's really important, because you never want the artist to be waiting on you or you to be waiting on the artist if you can avoid it. You'd always rather just be able to develop at full speed, and as things come together, they just get used, and you don't have to really worry about those sort of dependencies much. So what I kind of proposed for this was an asset tag system where basically we have any given asset in the game does have a primary type, and that is just whatever the asset generally is to the engine. So if the engine tends to think about things in terms of like, oh, there's a hero and there's a this and there's a that, then those are represented in the types, and those are the things where we know specifically we want to get back a thing of this type, right? So if we ask for a hero, we want to get back a hero, right? But then everything else underneath there, I was kind of saying maybe we could get that out of the concept of a bunch of tags, which are like IDs paired with values, and those IDs would be things like, oh, this is, a thing that says, for lack of a better example, like say the gender of the hero. Like let's say you wanted to have like a male and female versions of the hero, right? Well, maybe you have an asset tag ID that's like gender, and then you would just put in there, you'd assign number values to them, like, 0 is male, 1 is female, or something like this, I don't know. And hey, then you could even represent, anything in between genders if you wanted to, right? Maybe not all the creatures in this game have a binary gender, right? Maybe it's a more progressive game, and creatures in this game can have mixed genders or transition between genders or do all sorts of other things, right? Well, then the engine only has to know about that, and it can just go ahead and say that, and then if nobody's drawn a female hero yet, then it would just return a male hero if that was what we had in there, like the one that's in there currently. Although I'll be honest with you, I feel like our guy is a little kid. He's kind of, he's sort of androgynous. He's not strongly male, but he's sort of male. So we have that in there. If it asked for a female protagonist, there wouldn't be one yet, so it wouldn't return anything. So it would return the closest match, which would be the male one. But that if in the future you drop in a female hero, now you have that ability for the asset system to pick that. So when someone picks a female hero as their hero, they will get back the right set of art assets, right? And so that's kind of the idea, right? And the same goes for other properties. Like if I have grass and I want, tall grass and short grass, I can have an ID that's like the tallness of something. And then I can put in like 0 for the shortest, 1 for the highest, and anything in between. And it'll just, at first, if there's only one type of grass, I always get that asset back. But then as more grasses go in, I'll start to get back different grasses based on that number that I've put in, right? And so that all seems pretty reasonable. But, is it enough? Do we have to do more? I don't know. I feel like what we're supposed to do this week and start playing with this, see what we can represent with it, and try to play around with some of those characteristics that I think we might want to have of the asset system, and see if we can make it work. Now, we already made it work with arrays, which was the simple case. You notice that we don't have any of the array types in here anymore. We just ask them directly from the asset system, and so you could always dump more of something in, and that just works currently. But now what we want to do is start to talk about some of the more structural aspects. And so we do have one example of that, which is our hero bitmaps, and that's the thing that we want to start looking at today. So here is our hero bitmaps thing, and you can see that the way that this typically works currently is there's 3 parts to a hero. There's the head, the cape, and the torso. And so there's 2 things that we might want to try and tackle here. I'm not 100% certain which of these 2 we actually necessarily want to use, and I'm not sure how far we want to go down one of the paths necessarily, but I'll just sort of briefly discuss them so you can get an idea of what I'm talking about. So there's 2 ways we can go about doing this. There's one way, which is that the asset system itself has the capability of exposing information such as what constitutes a hero, right? In other words, it's entirely possible for us to say the engine doesn't really know specifically what makes up a hero. And in fact, it asks the asset system, give me back a hero and tell me what parts it has, right? So that's like, does it have a head, does it have a cape, does it have a torso, that sort of stuff, right? The other way of doing things is the engine is always the thing that knows, and it asks the asset system to give it back the individual pieces, right? And so these two ways of doing things obviously have different benefits and trade-offs and stuff like this. What I'm thinking as I say it, I feel like our game is probably going to be the kind of one where the game engine decides and just asks the asset system directly. Because since it's a procedurally generated game, what that means is we probably don't want to be asking the asset system what constitutes a hero. We will probably randomly roll what constitutes a hero, or have different unlocks that determine what constitutes a hero, and then that hero is dictated to the asset system, which is required to give back the assets that will form that procedurally generated entity, not the other way around. So what I suspect would happen here is that what we would want to do is say that maybe the parts of the hero are additional things that sort of get specified, right? Okay. So here's the problem that we have. For every one of these things, we have sort of an additional, we have a choice of whether we put the asset type, whether the hero's head is an asset type or whether it's a tag, right, underneath that hero type. And what I think would be relatively straightforward is if we make sure that everything that the engine thinks about specifically is typically going to be in a type ID, right? And the reason that I say that is because if I ask for a hero head, you can give me any number of heads from the asset pool, like a male or female head, or a skinny head, or a wide head, a fat head, all those sorts of things, right? But you need to give me back a head. You can't really substitute the head with something that's not a head. Like, you can't give me the torso in place of the head. It doesn't really make any sense. So that to me seems like it's not really a tag situation. That seems to me that it's more of a specificity situation, right? So it seems to me that we want like asset head, asset cape, asset torso, right? That seems to me like probably what I want, right? And then when I ask, and these are probably like, well, you know what? Honestly, I suppose now that I think about it, I don't even know if they're necessarily specific to the hero. Like, pretty much, anything could have a cape, right? I mean, at some level, I don't know that we need to split hairs about what kind of cape it is. So I might just say that we've got, maybe even child head or human head. I don't even know what to say about that. Maybe it's just head. Yeah, I don't know. I'm just going to leave it as just head for now. So those are new asset types that we could ask about. And then the other question is, well, with the way we did hero bitmaps, right? We've got those hero bitmaps for 4 different facing directions. That's why there are 4 of them here. And the facing direction, to me, that does seem like a tag ID thing, right? Because what direction it's facing, you could give me back something facing the wrong direction as a stand-in for the direction that I actually want. And furthermore, if my directions are very precise, I don't really need you to give me back a head that's pointing exactly like, say, 63 degrees off right or something like that. You could give me back a head that was pointing just somewhere, anywhere close to there, and that would be sufficient. So I feel like for our asset tags, we can now start to think about what that might be. We've got this asset tag here, for example. We could have a facing direction, and that's something that seems pretty clear about what that would be, right? That would be something, and I guess I could put a note here that this is like the angle in radians off of due right, right? So like the, the mathematical sort of circular standard facing direction. So now let's try, given just that very simple experiment, let's try to encode our hero into the asset system so that it's no longer a special purpose thing that sort of happens out here in a sort of way that we had a special case for heroes. Let's see if we can do it in a way that doesn't require any of that special casing at all. And so what I want to do now is I want to introduce some way, of course, of actually passing what you want for the asset tags. And the way that I think that I'm going to do that is probably with wide vectors at first. Maybe we won't do this later, but we're going to see. So what I'm going to call this here an asset vector. And an asset vector is just going to be a giant set of real 32s, right? That's all of the possible asset tag types that we had in here, like so, right? And so when you create one of these asset vectors, you can essentially go ahead and make an asset vector full of all of these reals. Whether this gets a little bit too unwieldy and whether we need to store them sparsely, I will worry about later. And so for right now, I'm just going to do the simplest possible thing and introduce that. And this will basically be a way of me saying that I want to pick an asset type based on something that isn't random, right? And so let's go ahead, like I said, try to write the usage code first. I had already put in that sort of pick asset function. I don't know where that guy ended up actually being. I think he's in here. Here we go, pick best. So what I want to do is I want to go ahead and write that. You can see right here that we've got this random asset from. And so what I want to do is make this basically be the same thing where I've got sort of a random asset from, but now I want to do something that's like match asset from or something like this, right? Or best match asset, right? And so what I'll do is I'll pass something like one of these asset tag vectors, right? Here we go. And this is like the desired characteristics. So this is the the match vector. In fact, I guess I already got it laid out here, right? So we'd have an asset vector, like so, an asset vector here. So I'd pass in what I want to match, how I want to weight those matches, and then I can just say, well, we've got the game assets. I've got the type of the asset that I want, and then instead of passing that random series, I'm going to pass those match vectors. And then let's see if we can implement that with our asset system, right? And so as you can see, like I said, remember when we wrote this, what we do is we just loop through the assets that we have, and we see which one of them has tags that matches the closest as possible to our match vector, weighted by whatever the weights are. And I'll talk about that maybe a little bit more after we implement this. For those of you who don't really understand how that works, I'll try to give you a little bit more information about that, since we never really talked about it in detail when I wrote that sort of as an exploratory function. Okay. So basically we want to do exactly the same stuff here, right? This is exactly the startup that we're going to use. We want to grab out whatever that asset is, and then assuming that there are some assets, we're going to take a look at all of the assets in series. So instead of doing it like this, what we actually want to do is do a for I loop here now, where I'll go ahead and do asset index equals whatever the first one is. And I guess we don't even need that for loop anymore, because we're just going to loop sort of between the bounds here. So there we go. I'm going to start with this asset index. I'm going to loop until the end of this particular asset, and off we go. Now, every time I encounter one of these assets, right, I'm going to take a look at that asset, and I'm going to loop through the flags. And I'm going to do that exactly how we did it here, right? And so what I need to do is find out where those flags are. And I believe the asset itself tells me, right? That's the way it should work. We've got the asset type, which told us all the assets we should consider. And then for each asset, we have all the tags we should consider. So there's our first tag index. Excuse me. There's that first tag index. There's the one past the last tag index. So, and for each one of those, we're going to grab out that asset tag, which again is just off of our global tags array. So for each one of those tags in the asset system, we're going to take a look at the match vector. We're going to subtract it from the actual value that the tag has. And that's basically the difference between what we wanted and what this particular asset prescribes. And then we're going to weight that by multiplying it by whatever the weight vector is for that particular tag. That gives us a total weighted diff. And so each time through the asset, every time we check an asset, if the diff that we come up with here is better than whatever our current best is, then we will go ahead and save that as the resulting asset, right? And I think that's basically all we need to do. I'm going to go ahead and make this work like that. There we go. We don't really need best index. we only need to save best diff because the result itself will carry the return value. So let's go ahead and compile that and see if I did anything stupid there. Oh, I forgot these are now .e's. There we go. I should say arrow e's. And that is a best match routine that loops through all the assets. Now, it's not particularly smart. It's not accelerated very well, so it's got to do a lot of work to check all these, and that may be a problem for us. So that's something that we definitely have to think about. And when we start to do a little bit more profiling and stuff like that in the future, we may have to start to think about how we want to make this stuff run faster. But again, we're not going to worry about that until we actually have some indication that it's going to be a problem, because otherwise we're just spending time in the wrong place potentially. So there we go. That's something that does what we needed to do. And so now let's take a look at actually calling that best match asset from some code that was actually using the hero bitmaps, right? So let's assume, just start off with go ahead and turning off those hero bitmaps entirely so that we just don't have them anymore, right? And so we can see everyone who's trying to use them. And here you go. You can see us grabbing the hero bitmaps out here. And if we take a look at what happens with those hero bitmaps, you can see that they get, I guess they get used here both by the familiars and here by the hero. It looks like, yeah, the familiar and the Monstar are only drawing the torso and the head. What I might do just for the moment, I might go ahead and disable the familiar and the Monstar so that we only have to work with one person, which is this guy, right? And see how we would go about specifying this stuff here. Well, you know what? Actually, now that I think about it, no, we don't really have to do that. That's actually probably premature. What I could do instead, there's a pretty easy way to port this, now that I think about it. All we really have to do is take this out and make this back into something that only, I think it was originally in Handmade .h anyway. I'm just going to go ahead and make one of those there, and instead I'm just going to say that there's a bitmap ID in each of these, right? And we'll call this hero bitmap IDs, right? Then in here, what I can do is where we were getting them before, where we do hero bitmaps, and we look up that facing direction, right? I'm just going to say, oh, okay, here's our hero bitmap IDs, right? And that I will actually set each of these members to be the appropriate, what the ID should be for the facing direction by calling the asset system right here. So I can basically emulate exactly the way that we were doing this before, right? And so what I want to do here is call that new function that we made. And like I said, write the usage code first. I want to make sure, before I go down this path any further, I want to make sure that it's convenient to use this function. So let's take a look and see if it actually does things the way that I want it to do it. So we've got our trans state assets. We have our asset type ID, which in this case is going to be, like the head and so on. So there's our asset head. Then we have our match vector and our weight vector, and those are going to be basically the same for the head, the cape, and the torso at the moment. So I'll just go ahead and make those and then use them in each case, right? So let's go ahead and do best match asset. Go. Best match asset, best match asset. So we have head, cape, torso, and that's really all we need. Let's take a look here. Set top down align. We don't really want that anymore. That is not at all what we want. Let's go ahead and delete that. Let's see. And so asset vector, match vector. So asset vector, weight vector. So what I want to do here, I'm not sure how exactly I want to set these. It's a little bit confusing because I haven't really thought it through too much. I'm going to do this in a very simplistic way at the moment. So we're going to kind of want to work with these guys a little bit more to figure out exactly what we want to do. But for now, yeah, we're just going to do the simplest possible thing and and just directly set the values. But I think I'm going to want some helper functions for this eventually. Is it entity facing direction? Is that the appropriate? I don't actually even know. Let's see. Military 2, yeah, so that's fine. All right. So I want the weight right now. Oops, I've got these backwards. I want the weight to just be 1.0 for right now. And I want the facing direction to be the only thing that we're matching against, so there we go. And when I'm calling these guys here, I need to pass the address, because that's a pointer-based value. So there we go. Oops. And let's see. And these are now dots. So there we go. And none of the two overloads, right, because that's not an address anymore, it's just a bitmap ID. So let's do that, and now we should be ported. Okay, perfect. So now what I'm expecting to happen now is absolutely nothing. Like, we shouldn't see anything because, of course, we haven't actually set up any of those asset tables. So what we want to do now is go ahead and set up those asset tables and see how they work. So here we are in the part where we would have to start setting those up, right? And you can see that we've kind of got this stuff happening here. So what we'd want to do is we'd want to go ahead and do a begin asset type, and we'd want to say that we're going to set, like, for example, the cape, and then we do an end asset type, and, I could go ahead and grab the right cape in here, right, and just add that in there. Oops. Add bitmap asset, assets, like so. And now we'd have the cape in there, and it would just always pick the rightward-facing cape, right? So anytime you ask for a cape, you're going to get the rightward-facing cape, right? Because that's the only asset that's in there, so it doesn't matter what tags you specify, you'll always get that one. And similarly, I could do the exact same thing for everything else on the hero, right? We've got the head and asset type assets. And again, this code I don't care about at all, really, because this is not code we'll ever actually use in the real game. This code right here is just to build the asset list as if it had already been built in an asset pack file. So this is really just whatever it takes to get something in there, because it's really all the query code and stuff that we care about. We don't care about at all the building code here, because that will never run at runtime at all. That'll be something that's done as an offline process. So there we go. So let's see. If I specify these now, we should get a complete hero facing to the right, like so. Oh, and hey, we also get the familiar head, which is also good, right? Now we have a problem here, which is that we have not done our top-down alignment stuff for these guys yet. And so we need to pass in that, and as well as like a sort of a v2 thing there, right? As a thing that specifies that. And I'm not sure how we want to do that exactly. I guess I can just do the divide. I guess I could, what I did before, if I remember correctly, is I went in and actually inspected what they all were. Seems a little bit tedious. Maybe we'll leave that for a little bit later and focus on still what we're doing here, and then I'll deal with that a little bit later on. All right. So now what I want to do is I want to be able to start adding in the different types of assets for the head here, the different facing directions. So what I'd like to do is make the head go different directions. So what I want to do is I want to be able to make the head go right. I want to make the head be able to go up, or I guess I should say back, and front, right, to represent that sort of rotational, that rotation, right? And if I add all those to the system, then what we get, right, is it just picks whatever the first asset is, because none of the other assets will ever be a higher match than it. So what I need to do now is set those assets to have some tags that are actually going to distinguish them from other things, okay? And so what I want to do there is I want to be able to set that asset tag for the facing direction, like so, right? I don't know if it should say asset tag or not, but we'll just say tag facing direction, right? I want to be able to say tag facing direction, and I want to be able to set that facing direction to something, right? Now, I don't know what these are actually, these aren't actually angles yet, because I think the facing direction stuff is still set to be integers, and the other ones will have to line those up. But this will basically give me something that will start to differentiate these assets by adding these tags, right? So I'm going to go ahead and put that tag in here. if I do add tag game assets, this right here is going to be the tag ID. That lets us know what type of tag we're adding. Then we have the value, which is what it should be set to. And what that has to do is that has to insert a tag into the tag table, right? And it's going to have to know which particular asset it was talking about, right? So since we haven't ever done anything like this before, you'll notice we don't have the right pointer in here. We need a debug asset in there for building. And what that's going to be is just a thing that remembers whatever the last asset was that we created, right? Like so. And so as we do that, I will do an assert here, right? Assert assets, this guy, debug asset. And whenever we sort of end an asset type, obviously we'll also set that debug asset to 0, like so. And that's all fine. So when we go to add a tag, what we need to do is we need to make sure that this actually gets set in the proper way. So what we have here is we've got, much like we had all that other stuff, we want a debug used tag count, right? And we want that debug used tag count to allow us to continue to add tags, right? So we're going to have an asset tag here where we basically do assets tags plus debug used tag count plus plus, right? And that allocates a new tag. And again, we would also want to assert here. It looks like I didn't assert this one for some reason. I don't know why. I'd like to assert that we're actually in the reasonable range, right? Make sure that that one pass less asset index is actually less than the asset count total. Just again, it's not like this is really an issue at all because this is stuff again that will all be done offline. But just while it helps in debugging to double check. That way you don't spend a lot of time trying to debug something that an assert could very easily have caught, right? So sometimes it pays to just throw in a few extra asserts in there, even if you don't think they're particularly useful, or even if you don't think it's very important for the code to be robust. It's sometimes you're just doing it to save yourself a little bit of time, right? So let's go ahead and do that. We set this up now. The first tag index, much like we were doing here, this sort of stuff, we want this to work exactly the same way. So we set this up to initialize itself with essentially a null range, right? And then every time we add a tag, what we would want to do is we would want to sort of advance that debug used tag count. And we also probably want to take that debug asset and increase its one pass last tag index, right? So we want to increment both of those, both the total number of tags that we have written so far, and then also the for the asset that we're actually adding them to, we want to expand its range as well so that it knows that it has another tag now. Once we have that tag, we just set the ID and the value, and that's really all that we need to do there. There's really nothing else that we're going to do with the tags. So now that we've got that, if we go ahead and this end asset type is really superfluous. It's mostly just for error checking now, so we could actually get rid of that if we wanted to. It doesn't really do anything, but that's a separate issue. So in here, you'll notice we don't allocate any tags at the moment. You can see that the tag array is totally not allocated, so we would crash pretty much immediately. Well, we wouldn't crash, we'd assert that there's no room left in the tag table. So what I need to do, again, is just allocate some room in the tag table for this test stuff. So I don't know how many there's going to be. Let's just say that there's a bunch of them. I don't know how many there are, but it doesn't really matter. A lot at the moment. And again, we'll know the exact number normally because we'll be loading it off disk. So that's really not an issue going forwards. So let's go ahead and set that up and compile. Now we should probably step through this and see that everything's going, but I just want to run it. There we go. So you can kind of see now that we got exactly what we wanted, right? Those tags are now allowing the asset system to match properly. So now we no longer specifically code anything about how the facing direction stuff works. We just ask the asset system and it returns one for us. And as you can see, since we haven't added any other assets for that cape and the torso, they just stay giving us back the one bitmap that actually is added. And so now, without, again, changing any other code, this is this kind of nice thing about the system. I can just kind of come in here and pretend that, if this was the asset system, I can just pretend that what we did is we loaded, the new asset pack file that has this more stuff in it, right? And off we go. So if I actually define these guys so that now all the directions of all the stuff is in there, you can see we've got our hero back. And now the other nice thing too is our hero is going through the asset system, which means he's delay loaded and all that other stuff. So that's all good news as well. Okay, so that's all cool. Tag matching is working nicely. I do think, however, that this is not a particularly good way of doing facing direction. I feel like facing direction should be more, more general than that. It just doesn't seem like a very good idea. So what I want to do is I want to take a look at where that facing direction stuff is actually set. I want to maybe change that to something that makes a little more sense. So let's take a look. Here we are in sim region. You can see that what we're doing here is we're sort of taking a look at whether we're, where we're moving in X or Y, and we're encoding that in there. And I feel like maybe what we would want to do here is just like an ATAN2 or something to figure out what angle the hero is pointing and actually use that as the facing direction. That way we could introduce diagonal sprites if we wanted to in the future, if we decided that those were a good idea or other stuff like that. It would just give us a little bit more, fidelity there in our character sprites, if that makes sense. Now there is something that's a little bit nasty about that. So we do have to think about this a little, and I'm kind of glad that I decided to do this, because this brings up a thing that we would probably have to support in our tag system that right now we really aren't supporting, right? So let's go ahead and talk about that, because it's a very interesting point, I think, and probably will have some ramifications, right? In fact, I think someone actually mentioned this. They were like, well, you need to have different matching functions. And I said, well, we don't know yet, right? And so here's an example of where we might need to have one. I don't know if this is exactly what they meant, but I think they were asking along these lines anyway. So let's say that what I want to do is I want to match bitmaps against the facing direction. So here's like an example of a facing direction, right? Here's another example of a facing direction. Here's another example of a facing direction, right? And so in here, what I do is I have the different drawings of the guy, and so here he is facing that direction, and here he is facing that direction. He's some kind of a fish mouth thing. I don't know what he is, but that's just what he is. And here he is facing that direction. Okay. Now, if I encode these by the angle, right? This is maybe 0 degrees. This is something like, maybe 80 degrees. I don't actually know. And that's maybe something like, I don't know if that's 180 and that's 90. That's going to be like, let's say that's 150. I don't really know. Maybe 160 probably, more like. 160 degrees. So if I encode these by the angle, and I pull them out, I'm going to get what I want. I put in, let's say 10 degrees, and I'll get 0 properly. It'll match the closest. I put in 75 degrees. That'll match the closest. I put in 125 degrees. This will match the closest. And it's going to do roughly what I want it to do, and that's good. But I have a problem, and that is what happens when I go here and I put in this angle, right? Which is, I don't know exactly what it is, but it's something like 300 degrees. What am I going to get back? Right? I want to get back this guy because of the 3 things that I put in the asset system. He's clearly the closest. But the problem is he's actually going to match this guy because 300 is closest to 150, not 0. Right? And that's because this parameter is periodic, right? Not monotonic, right? It does not just keep increasing, it wraps around. And in order to correctly obey, in order to correctly encode that notion that this thing is wrapping around, I don't really have any way to do that with something that just matches based on the value. The matching code needs to do some logic to handle the fact that it's periodic and match on a periodic basis. Does that make sense? Hopefully that makes some sense. So yeah. That complicates matters a bit for us, right? That makes things a little bit more difficult, because what we'd have to do here is say, all right, let's assume that you're going to take these things together. We would need to, for every value pair that you put in, we'd first have to see whether they were a greater than 180 degrees apart. And if they were, we'd have to like flip one of them, right? So in other words, flip is probably the wrong word. But basically what we need to say is, okay, this is more than 180 degrees apart. So really this guy should not be whatever angle he is. He should be 300, he should be 360 degrees plus whatever he was, right? So let's say he was, 10 degrees or something like this. But these guys are more than 360 degrees apart. Well, I should go ahead and map him by adding, right, that 360 degrees in there, right? Or the other way I could do that is say the input, when it comes in, if it's more, then I'm going to go ahead and subtract 360 degrees from it, which would bring it to be, this would be negative 60 degrees, which would make him match 0 closer again, right? So we need a little comparator in there, and the only way that we would know how to do that comparison is if we knew per ID which ones were periodic and which ones weren't. And that is kind of what I mean when I say we might need different comparison functions. Now at the moment it's totally fine, because what we're doing is we're just matching on a single value that kind of is set to something or it isn't. But when we start talking about those values that are going to be sort of periodic like that, that's something that we have to think about. And I don't know how many of these we would have, but at the very least we know that many things will probably have a facing direction, and that facing direction is definitely periodic, right? There's no question about that. So that suggests to me that this is something that we would want to add. It just seems like what we would need, right? So I don't know. Let's go ahead and try that. Let's go ahead and play around with that a little and see where we end up, right? So what I'm going to do here is I'm going to say, okay, let's go to Handmade Intrinsics. I don't know if we have an ATAN2. We do. So the ATAN2 would let me get back what that angle actually is. So what I could do here is say change to using the acceleration vector. What I could do is say, all right, if that's what we wanted to do, we can go ahead and say, entity facing direction equals ATAN2, and it's going to be dpy, dpx, like so. That's going to be that facing direction, and I'm going to change that to now be a floating point value, and this is just going to be an else, right? So yeah, something like that, right? So if I do that, I need to go grab that facing direction and make that into something that's actually going to be a floating point value, like so. And now the facing direction is actually an angle. And so what I'd want to do is actually specify these guys in the asset system when I actually, and I won't need this cast anymore as well. So in the asset system, what I want to do now is I want to change these to be, basically like, angle right, angle back, angle left, oops, angle front, something like that, right? 0.0f with angle right, 1.0f with angle back, 2.0f with angle left, and 3.0f with angle front. And so then I can just go ahead and define these. Angle right is obviously 0, 0. Angle back is going to be half pi, right? Angle left is going to be just pi. In fact, I could just make these all in terms of pi's, like so on. Or do people like tau better? I know a lot of people like tau better. Do we have a pi 32 or a tau? Does anyone know? Do we have a tau? What do we have? Do we have any of these at all? Do we seriously not even have a pi? There it is. There's our pi. All right, 1.0f pi 32 and 1.5f pi 32. All right, so there's our angles. They're in radians, so that's why it's no pi, half pi, 1 pi, 1.5 pi as we go around the circle. Those are specified now. And so in theory, this should probably, maybe it will work. I don't know. So almost. But not for down. Down does not work, which is interesting, to say the least. I'm not entirely sure I know why. Yeah. Yeah. I don't know why that would be messed up necessarily, but it definitely likes to pick the wrong facing direction there for our front guys, and I am not exactly sure why that would be. That is something because I discussed the matching bug there, but that's matching. That bug would only affect things that were sort of closer calls, but down should match pretty much exactly, and that's not really a periodic issue or anything like that. So yeah, that's very weird. And it looks like left is not working properly at the moment either. So we got some weird stuff happening here. Yeah, so I want to take a look at what's going on there. So I'm going to take a look at first the entity facing direction stuff to see what that is actually going to be equal to velocity-wise. I guess I could also, yeah, that's what I'm going to do first. I just want to take a look and see why it doesn't change at all. So let's go ahead and take a look at that first. I want to see what we're actually getting here. So let's go ahead and open up File. We want Handmade Sim Region, and I want to see. Let's see here. I want to see. You know what? I don't even care. I'm just going to search for ATAN2 because that's got to find it. There we go. All right, I kind of was not expecting my any entities to have a velocity at the moment. Oh man. And they're denormals. Oh, well, we're still in debug build, so let's go ahead and turn that off first of all. So we can view everything appropriately, like so. Okay. It's so much slower in debug mode, it's crazy. All right, so here we go. Right, I'm moving downwards now. I flip over. Let's break in here. Let's take a look. Entity, our DP. Is this the hero? It is. Negative E. So there's really no X component. It's just a very large Y component. Negative 1.4. So that's a pretty huge negative Y. So I would expect the entity facing direction to come out to be something reasonable here. Let's actually see if it does. Negative 1.57. And so let's see what 1.5f times 3.145 is, like so. That is not what I would have expected. Maybe my math is so rusty that I just am totally forgetting how to use my ATAN2 properly. Do I actually need to normalize these guys first? I didn't think that would have been the case. So why would we come out? So this is what actually would be facing downwards. Oh, duh. Right. So this is actually the periodic matching problem that I was just talking about. Never mind. These are just, right, it just gave us the negative angle. Duh, because ATAN2 doesn't do 0 to 360. It does negative 180 to positive 180. So this actually is exactly the bug. All right. So yeah, this is exactly the bug. I guess I'm glad that it was what I said we were going to have to do, but I'm not glad that I was too dumb to immediately know that that would happen. So yeah, if we wanted to fix this right, we could also go ahead and right afterwards do like an entity, if entity facing direction is less than 0, entity facing direction plus equals 360, right? So pi 32, 2.0 pi 32, something like this. And that would, correct it back down, I believe. So that we could just verify that it's working still in the jankier way. I'll have to turn that off. All right, so there we go. Yeah. So we do have the bug, and that's good because now we would like to go ahead and fix that, right? We'd like to make it so that that can match on the periodic boundary and that everything is fine. And you can kind of see even right there, I get a nice bug where it's not quite matching with 0 properly. Like he's still gonna, until I give him a little bit of upwards velocity, he still matches more closely with the down value because his velocity is probably still pretty small in terms of upwards velocity, right? Yeah. All right. So we have exactly that problem. I think we can probably wrap it up for today because I feel like we've done basically everything that I want to do. And so talking about how we want to handle those variable types will be the thing that we'll do. We'll start on tomorrow, like meaning how we want to add the tag types. So that'll be our goal for tomorrow. We'll be adding the tag types. So I'll put that bug back in there, unfixed now, so that it's more blatant. And that's exactly what we'll do tomorrow. Is we'll go ahead and work on getting that correct because it shouldn't be too much work. But I don't want to start on it today because it's kind of a new system. All right. So that sounds good. Let me go ahead and go over to the Q&A here. Let's see. There we go. So if you have any questions on what we did, please make sure you prefix your question with Q:, and then I will be able to see it and answer it. Abner Coimbre says, it's a bit delayed, so bear with us. Very well, I will bear with you. Repeating the question for the pre-stream. Oh, that's not on topic. Let's see. Robot Chocolate Dino. Could all tag matching be periodic and then we just make the period really large when we don't want it to wrap? I like the sound of that. You may be onto something there. I need to think about that a little more. I'll think about that, and tomorrow we will talk about that when we go to implement it. We might be able to do something like that where all the tags are handled uniformly, but they have sort of parameters that let a single set of quick math functions give us a bunch of options to play with along those lines. That's a good idea, Robot Chocolate Dino. The hero has separate bitmaps for his sprites. Will this be a recurring thing for other kinds of sprites in the game? Yes. Lots of the sprites will have different pieces so that they can kind of be animated like bouncy. And I mean, obviously, just like every game, you're going to be able to like get different capes or stuff, right? And so you want to be able to swap out different capes if you get like a new cape that's, magical or something, right? So you want to always have the ability to to have more granular control over what you're drawing. From a scale of 1 to 10, how dumb do you think Windows API is? The answer is you can't assign a single number because it depends which API you're talking about. Some of the kernel APIs are very well designed. So are you talking about those? Or are you talking about Windows Event Tracing, which is probably the worst API ever designed, like, ever? And so I think the answer could be a 1 or it could be a 9 or a 10, depending on which part of the Windows API you're talking about. So I think it's impossible to assign a single number. And that is not surprising because it wasn't like the Windows API was written by one dude, right? The Windows API is written by many people over many years, and some of those people were very, very good at what they did, and their APIs probably are the ones that we look at and go, okay, that's a pretty good API. And then other people who had no idea what they were doing wrote stuff, and those aren't. And so that's just the way it goes. For the getting the angle you want, couldn't you just divide the angle by 45, giving you a number to switch on? You could go a step further and take the modulus of the number of angles you want. No, I don't want to do that anymore because the idea here is now the engine should ask for things directly without doing that. It should just say, here's the actual angle, and then whatever the art asset pack happens to have in it, it will get back the closest match. That way, if you add more art sprites to it, it just gets smoother. Tau is clearly the superior constant. Please remove every instance of pi in the code. I guess you feel very strongly about that. If you really want the pi stuff to go away, do we have a good? Where is a good tau out to many digits? Give me a good. I don't want to do 2 times pi because then I'll lose a bit of precision potentially. So give me the value of tau. How come Google doesn't have the value of tau? Shouldn't that just come up? They have all those little drop downs and things that come up. Let's see. So do we think we trust this source? Let's see here. There's some tau. That's more tau than we need. So handmade.cpp.h.platform, whatever. So here we go. Tau undefined, tau 32, 6 point, some shit, like so. So there's some tau. And if you want to, we can go ahead and replace the places where it makes sense. Let's see. So here's tau, 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 tau. So you cleaned up a bunch of 2.0s there, right? Hey, look. Tau. That's why tau is better sometimes. It's just because a lot of times you're talking about 360 degrees, so it's just cleaner. Oh, and look at that. We already were doing one of those re-entry sort of things too, weren't we? Right? So there's that tau, and then here's this tau. So we have tau 32, tau 32, right? Tau 32, tau 32, and that's probably it. So yeah, there you go. What is your opinion on people who use spaces instead of tabs? I think spaces are good. I don't think tabs are a very good idea. They're kind of a half-implemented feature, and usually when you try to use a half-implemented feature, it goes poorly. Why did you use a tangent of the angle for determining the asset? So the reason is because what I need to do, right, what I have is I have a direction vector, right? And so this is my velocity, right? Or dp as we call it, right? The delta of my position. So I know that vector. And what I want to do is I want to be able to look up, based on that, I want to be able to look up an art asset. Now, I don't want to look up the art asset by two independent numbers. Like I don't want to look it up by a dp.x and a dp.y, because I really only care about the direction this vector is heading. I don't care about its actual magnitude or anything like that, right? So what I wanted to do is I want to encode this into one float, right? One floating point value. And so the way I can encode the direction of the vector into floating point value is using an angle, right? Obviously. An angle is a really easy way. I can just say, okay, wherever this vector was, I just want you to give me an angle that says how far off of, off of the sort of the x-axis that is, right? So the way that you convert a vector into an angle is by using the arctangent, right? Because if you look at what happens, if I draw in some arbitrary vector here, I know that the vector has an x component, right, and it has a y component, and what I want to do is I want to find this theta, right? I want to find out what theta is. I want to know what that angle is. Well, as you know from grade school trigonometry, right, tangent of theta is actually equal to this y over this x, right? It's the sine over the cosine of that angle, right? And so what I want to do is I want to do the inverse of that, right? I know the y and the x and I want the theta. So instead of tan, what I want to do is do the inverse tangent, right? You could think of applying the inverse tangent function to both sides of this equation. I would get inverse tangent of tangent equals inverse tangent of y over x, right? So inverse tangent and tangent cancel, and I just get theta equals tangent inverse of y over x, right? And so what I could do is I could call atan, right? I could say, give me the atan of y over x. I could do that, right? That's one way I could have done it. But what happens there, if I call atan of the quantity y over x, the problem is the signs disappear. So I end up with, if it was negative y over negative x, right? And think about what these mean. Let me just draw them out for you just so you're totally clear on this, right? Here's something with positive x, positive y, right? Here's something with negative x, positive y, right? Here's something with positive x, negative y, and here's something with negative x, negative y, okay? All of these have exactly the same x and y values other than their sign, okay? All of these could be like, this could be 1, 1, and this could be negative 1, 1, right? And this could be negative 1, negative 1, and this could be 1, negative 1, okay? So now, when I asked for the tangent, well, I wanted two very different values here. I wanted that value for this vector. I wanted that value for this vector, right? I wanted that value, or negative this value, for that vector, et cetera, right? But with atan, it would have no idea which one of those I meant, right? If I passed it positive x over positive y, or negative x over negative y, it's the same result. The division is the same, right? Negative 1 over negative 1 is 1, and 1 over 1 is 1. They're the same. So it has no idea which of these two vectors I'm talking about, right? So it just gives me back a representative angle that's what could have had that tangent, and it's the wrong actual angle for our purposes because we care about what quadrant the vector was in, not just how much the deflection was off of some axis, right? Because basically what that's doing is it's saying, well, you know what? I don't care whether you're talking about this deflection off the negative axis or this deflection off the positive axis. I'm just going to give you back what the theta would have been in either case. That's not what I want. I want you to differentiate between those, right? So atan2 is a much more powerful and useful function for computer graphics because what it does is it takes both the y and the x and it uses their respective signs to properly give you the angle that relates to the vector that you actually passed in and not just a example theta that would have worked for deflection off of the closest axis rather than the universal x-axis, x-positive axis. How many spaces? 2, 3, or 4? I use 4 spaces for my indentations, but you know, you should use whatever you want to use. Will you implement asset loading priority? For example, the player should probably load first so that you're not invisible in the beginning. I don't know that we'll implement asset loading priority, but what we will do is we'll pre-fetch stuff. So what we'll do is we'll like try to start the asset loading happening long enough before we need assets to make it so that they aren't missing when we need them. Would it be a good idea to switch to using matrices for rotation so further down the line it's easier to implement scale and transform? So I'm not sure what you mean by that. Right now we basically do use matrices. We just never called them that. Like we have an x-axis and a y-axis and they can be scaled. And that's how we're doing rotation. So we're not actually using angles for rotation, if that makes sense. If you're just talking about this encoding, this is just encoding for the asset lookup system. And no, I definitely don't think we should use matrices for the asset lookup system, because then you're trying to match on 4 tags instead of 1 tag just to figure out what direction something's going, which doesn't really make much sense, especially because you probably want the scale and the rotation to be separate matching, which means you don't want them to be missable. Like you don't want them representing the same quantity. You want separate quantities for how big something is versus what direction it's facing. Maybe this is something I missed out on, but are using CMass ATN2. Yes, right now we have not replaced the C runtime libraries. Math functions, that's kind of a topic that I'm not sure what exactly we'll do there. I'll do it on stream, but that's definitely going to be something that not everyone probably cares about. But basically what we'll do is we'll go ahead for our ATN2, we'll actually implement a little mathematical guy who does the ATN2. In SIMD, right? So probably, you know, it'll do a 4-wide ATN2 probably as well. I don't know if we'll ever actually care about that, but really like our ATN2 will probably operate on 4 values at once as well. All right. So due to E3, looks like it's probably a slow day, I'm guessing. What happened? Why is my... Weird, my hex chat says there are no operators on the channel and there's only one person on the channel, which is me. And yet I see stuff streaming by, so yeah. Anyway, so I think now would be a good time to call it. And yeah, we'll be back tomorrow. Still in the middle of E3 madness, I'm sure. But we'll be back tomorrow. To go ahead and talk about how we want to do periodic matching of asset tags, but it looks like things are going pretty well here. That was pretty easy, and now we've got a system where we can dump assets in that have properties, and those properties will be properly obeyed. So that's a good thing. So thank you everyone for joining me for another episode of Handmade Hero. It's been a pleasure coding with you as always. If you would like to follow along with the source code at home, you can always pre-order the game, and it comes with the source code. You can do that at handmadehero.org. And then you can go ahead and download it every night after I'm done. If you want to ask questions, we do have a place for that. There's a forum site which has a place to ask questions. I answer and other people answer on there. It's also got ports to Mac and Linux from the members of the community, so if you're trying to do that, follow along on a non-Windows platform, that's a good thing to start with. There's also a Patreon page if you want to support this video series. That's a very nice thing to do, and we have a subscription there you can pledge to. And we also have a tweet bot that tweets the schedule to you, so if you want to catch the series live, that's the thing to check out. For now, have fun with all of the E3 craziness that's going on. I hope to see you guys back here tomorrow. Same time, same place, 5 p.m. Pacific Daylight Time on Twitch. And and yeah, we'll be right back with our asset stuff, which seems to be going pretty well, so I I feel like we should probably be able to wrap it up fairly quickly, and maybe we can spend the rest of the week just looking at how we want our asset files to be structured and stuff like that. So thanks everyone for tuning in, and I will catch you tomorrow.